Here are a few examples of comparing two means, and I'm not going to go through and explain every single thing on these or read the questions to you. Okay, you can read them and pause the video. Okay, and I'm going to go right on down to part A. Okay, just to try to keep this as short as I can. Okay, so it asks you to construct a 98% confidence interval for the difference of population mean times that men and women spend at the gym. So a 98% confidence interval. You do x bar 1 minus x bar 2, plus or minus your t star value. That 2.492 is coming from your t distribution if you have a 98% confidence interval. And this will be 24 degrees of freedom because that's your smallest n minus 1. Okay, so 25 minus 1, 2.492. And then the square root of your first sample, standard deviation squared divided by your first sample size, and then second standard deviation divided by your second sample size. And when you do that calculation, your margin of error should be about 3.44. And it might be a little bit different with rounding, but it should be very close to that. So your confidence interval goes from negative 7.44 to negative 0.56. Okay, and another way to write that, the mean for the difference in the mean for the men's time minus the mean for the women's time at the gym, we're 98% confident that this interval contains that difference in means. Okay, so what does that interval seem to suggest regarding the mean times of men and women? And this is really the whole point of doing these intervals and tests, to actually explain what it's telling us. Okay, so what conclusion do we draw? Well, here, notice how both of these numbers are negative. So what that means is when you subtract the men's time minus the women's time at the gym, we expect to get a negative answer. Okay, so somewhere in this interval here, there's all negative numbers. So we expect that difference to be negative. Well, when you subtract the men minus women and get a negative answer, that's telling you that the second number was larger than the first number. Okay, so that appears that the women will spend more time in the gym on average than the men. Okay, so it seems that men spend less time than women because the entire interval lies below 0. Now, if we would have just defined our groups in the opposite way, so rather than doing 47 minus 51, if we just flip-flop those, that would have made this a positive 4. Your margin of error would still be the same because nothing changes over here other than flip-flopping these two fractions, but it's still going to give you the same number inside. All that would do is make these numbers positive now, which just means that we did the women minus the men and got positive answers, meaning the women were larger than the men. Okay, the times for women were larger than the men. Okay. Okay, the other thing I'll bring up is just suppose this was negative 7.44 and this was positive 0.56. So if you had opposite signs, then to answer this question, that would suggest that the mean times for men and women could have been the same. Okay, so our conclusion would have been that there's no difference in the time they spend. No matter how negative or how positive these numbers were, as long as 0 is in your interval, that implies that the mean difference could have been 0, meaning the population means could have been the same, or no difference in the means. Okay, part C here, testing the claim that men and women spend the same amount of time at the gym on average. Okay, so here, testing a claim, so we have a hypothesis test. So we set up our hypotheses. Okay, the null hypothesis will be that the time they spend are equal, and that happens to be the claim on this one. Okay, that they said they spend the same amount of time. And then the alternative will be that the mean times are not equal. So we create a rejection region for HO. So we have our two-tailed test now. Alpha is 0.1, so you divide that into 2 to get 0.05 on each end. So there in our t distribution, when we look up 24 degrees of freedom with 0.05 in one tail or 0.10 in two tails. Okay, so we have 0.05 in one or 0.10 in two tails with 24 degrees of freedom. That's 1.711. Okay, so we get plus or minus 1.711 for our rejection regions for HO. Okay, so now we look at our test statistic, we calculate it, okay, using the formula, okay, and then we end up with negative 2.898 on this one. So that test statistic is out here to the left. So if the means really were equal, getting this test statistic would be unusual. Okay, so getting a sample mean of 47 of the, difference in means of 47 minus 51. So getting that -4 difference would have been unusual if the means really were equal. Okay, so that leads us to reject the null hypothesis, giving us evidence to reject the claim that they spend the same amount of time. Okay, moving on to the next example. Okay, a drug company may claim that certain drug decreased cholesterol levels by more than 15 units. To test this claim, we form hypotheses, collect a sample of size n, calculate the test statistic, and then make our decision. This would be an example of a matched pair design because you need data in the form of before and after, and then calculate the difference in cholesterol levels for each individual. Okay, so each individual is going to have a before and after cholesterol level. So that's matched pair. Okay, whatever that difference is, it's then compared to a value of 15 in this case, because they're saying that the drug decreases levels by more than 15 units. Okay, so the null and alternative hypothesis for this example goes back to the one sample test. Okay, so HO will be that mu equals 15, and then the alternative is that the mean is greater than 15. Okay, so here, even though with the matched pair that we had two different data values like before and after, it's still only one sample. Because what that sample is, what you're looking at here, is the decrease in cholesterol levels. That's just one number for each person. Okay, so one person may have decreased by 30 points. Another person may have decreased by 2 points. Another person may have gained 5 points in their cholesterol level. But there's only one list of numbers, which is the before minus after. Okay, so next thing to compare that here. Now, suppose we are asked or interested in comparing the decrease in cholesterol levels between two groups of people. The first group of people, called the treatment group, will take the cholesterol drug. The second group of people, called the control group, will take the placebo pill, or a sugar pill. There is still data of the form before and after for each individual in each group. We may then compare the mean change in cholesterol levels in each sample group, so those who take the pill and those who don't, to make an inference for the population. Does taking the cholesterol pill result in a larger decrease in mean cholesterol levels than those taking the placebo pill? Okay, so that would be the question that we want to answer. And this is something that a drug company would do. It's an example of a study they might do. Okay, so they would give one group of people the pill, another group of people a placebo pill, which is not actually the medication. And then they could compare the mean decrease in each of the groups. So is the mean for those who take the drug equal to the mean who took the placebo pill? Or is the mean decrease of those who took the drug greater than the mean decrease of those who took the placebo pill? Okay, so you need to see the difference between a question like this that has two means compared to the first example where you're just looking at is the mean for the group greater than a number or less than a number. Okay, so along those lines, okay, you can read number 3. Okay, they just give you two different groups of people. I'm not going to read through it for the sake of time, so you can pause the video if you need to. Okay, we'll go right into the question. a 99% confidence interval for the population mean difference in the decrease in cholesterol levels between the two groups. So we're doing a confidence interval for the mean difference in the decrease in the cholesterol levels. So now mean difference means we're looking at the difference in means. So now we're using that longer formula where you have to subtract the sample means. You're using 2 samples now. Okay, so from your data in the question up here, okay, this is the substitution. Okay, and your margin of error when you do those calculations is about 2.15. So your confidence interval, 9.85 to 14.15. Okay, and again, the significance of that answer, notice how when you do the mean of those that took the drug minus the mean of the placebo, so the drug minus placebo, you get positive answers. Okay, which means you did a larger number minus smaller. Okay, so you get positive answers, you did larger minus smaller. So what this interval would kind of lead us to is that those that took the actual drug had a larger decrease than those that took the placebo pill. Okay, and then moving on to the last question, using that same information. Okay, now this hypothesis test. So at alpha's 0.01 level significance, is there evidence of support that the population mean decrease in cholesterol levels is greater for those who take the drug than those who don't? Okay, so we set up our hypotheses. And if you need to pause the video, go ahead. Okay, and then create a rejection region. Okay, so is the mean for the drug greater than the mean for the placebo? Okay, that's what we're claiming. Our rejection region is anything to the right of 2.39. So that's just using an alpha 0.01. And then your degrees of freedom from the first page. Okay, which was 74. Okay, because 75 was your smaller sample size, so 74 degrees of freedom. So you'd have to go down to the 60 to get 2.39. Okay, so make sure you can find that. Calculate your test statistic. And then 14.817, that's way out here to the right, which tells us we're going to reject HO, and there's enough evidence to support the claim that the mean decrease is greater for those who take the drug. Okay, so it looks like the drug is working. Okay, another thing I just want to point out here again is that this -0, it doesn't have to be 0 there. Okay, so what they could have said is the mean difference, say like mu1 minus mu2, is that greater than, say, 5? Well, then you would say mu1 minus mu2 equals 5, so you'd have 5 up here instead of 0. Okay, so they might be interested in really examining, well, how large is that decrease? Is it larger than 5? Is it larger than 8? Is it larger than 10 points? Okay, so if they did change the wording in that, so is the mean difference greater than 7? Okay, so the change in cholesterol level greater than 7, then you would have mu1, or mu for the drug, minus mu for placebo greater than 7. And then the null would be mu1, or mu for the drug, minus the mean for the placebo equals 7. And then this will be a 7 over here instead. Okay, and then just do the arithmetic on it, but that'll give you a different test statistic.